Okay, welcome everybody. Today is the 1st of March, sometimes called Fat Tuesday, I guess, in some places. This is the Dallas Personal Robotics Group Robot Builders Night Virtual. And we will do the usual tonight and just go around the table, talk about updates on our robot projects and related topics that surface. So I put a Q in the chat here. And then after that, I'll just sort out who wants to present on updates and ask questions. So we'll lead off with Pat, then Ross, then John, then Kareem, then free for all. So Pat, take it away.
So last week, I just wanted to give a little bit of an update. Last week, I was working with my robot and trying to figure out why it was curving to one side or the other. I did manage to get it going fairly straight. I am having trouble with the BNO 55. I don't know if it's a latency between the signal coming from the BNO, coming before the feedback on the motors. There's about a 40 millisecond delay on the motor signal coming back into the Raspberry Pi. So it takes about 2 communication cycles to get everything to coincide. So I was having trouble getting it to match. Incidentally, I did get it to go, I would say, fairly straight. After about 16 feet, I was out 2 inches. Basically to one side or the other. So I'd really like to get the BNO working, but I ran into another problem. So I've been using ROS as my communication background in my Python programs. So I'm not using really anything but the ROS communication. And the problem I ran into is I use a batch script to launch, to start all my Python programs, all my scripts. And unless I'm playing in the ROS world, that isn't going to work at all. So where if I manually launch them each in a window, I can communicate. If I try to do it from a batch script, it just fails. So I'm sort of stuck. I've been scratching my head to see which way I want to turn, or do I want to dig deeper into the ROS system and start going through with the proper launch files and start to use all the other overhead that goes with ROS. So I'm questioning if I want to dive deep down that path. And so I did find a little bit of news on MQTT, where is if I set the retain flag to true, that it should remember the last value that gets pushed in. So when I read it, it'll read that value out of the queue. So it'll overwrite whatever's in there and keep the last published value for other processes to read. So I'm sort of toying with going back to MQTT as a communication background for my programs. I sort of like it because it's got a broker that runs in the background on the main OS. And that takes a lot of overhead out of the programs as well, that they don't have to serve up the communication for everybody else. So that's about it for me. Just a short little update.
So Pat, one thing I've seen people do is delay all the input data, so it's matches with the latest data you have, so everything lines up that way.
Yeah, well, that's what I was thinking of doing with the BNO was to put it into a queue inside the program and just do a word shift.
Yeah.
So I would shift it down 2 words, and then I would read the one that's coming out on the second write cycle.
Yep.
So that's what I'm thinking of doing there. I'm still trying to get the values to work with each other. I'm trying to read the gyro, and I don't know if it's in rads per second or if it's in degrees per second. It looks to me like it's in rads per second. And it's so far, it's still nowhere near the value that I'm getting out of my motors as far as my encoder counts if I look at degrees per second or rads per second. The two of them just don't seem to match up.
Well, Carl's not around to manage the queue, so I guess Ross is up next.
Oh, okay. Well, I just wanted to share with you guys what I got going on. I'm gonna try to share my desktop here. I'm on a mobile device, so if it all goes weird or something, I apologize. Let me just see here. Share screen. People see everything on my screen, including notifications. Yes, start sharing. Start now. All right, everybody see you? See yourselves?
Yep.
All right. Are you seeing some pictures?
Mm-hmm.
All right. So I started off this here shows you the that it's not Lego. It's the I was saying it's the Play-Day compatible, but it basically made a multi-tiered chassis. Here it is sitting in its cradle. I just have to keep it from accidentally rolling off the table when I'm working on it. I got IR and sonar front and back, and on the sides I got IR, analog IR on the side. This is kind of the guts of it. It's Mega 360. Mega 2560, dual H bridge, the DB 6612, and I soldered up a board here for power distribution, and I got installed a Bluetooth module, HM10 Bluetooth module, and I put a Bluetooth app on I have one on my tablet and on my phone. And this is the open loop control testing that I did today earlier. So it goes forward, goes backwards, and then drives in various circles, large circle, and obviously can do different things.
I think he meets the criteria for a gold star. What do you guys think there?
So it can pivot around, and yeah, I can do it in just kind of degree increments like that. That's just me just, stupidly hacking at it. But I did have it doing some kind of some automated, roving kind of behavior. But I've since deleted all that code, and I'm starting over with a different approach to it. So my goal here next is to use the Bluetooth serial communication to link it up as a node, hopefully, so that I can start running ROS on my laptop and controlling it that way. I think that's probably going to be for me the best learning route to go. I can still, of course, keep it like this is all running LMX in the background. The same that's the software that David Anderson started me off on, and so I'm just going to keep it as is until I get maybe a board that's going to kind of run a version of Linux on it. I was thinking about upgrading this with something better, but I think I'll actually build a larger aluminum chassis or something. I don't know. Not sure what the next project will be, but this one isn't finished yet either. So I'm going to stop in sharing here now if I can. Let's see here.
Working with the Lego bricks, do you ever run into issues with the bricks coming loose?
Well, what I do is I just take a healthy dose of this here super glue, and I don't have any problems with that. I just basically made the chassis. It's 3 levels, 3 tiers. Yeah, this is a rechargeable lithium ion battery pack in the back, and so I can plug it in USB, and then it runs the Arduino and the motors also with the power distribution board that I have. So the top plate is sorry.
So I assume you haven't superglued all of the joints, just a few of them.
No, not all of them. Like this is actually 2 of these. They're what 100 16 centimeters by 16 centimeters plates. 2 of them sandwiched together and super glued together, and this is super rigid. Like I'm having a hard time bending that, and that's just two of them. And then each pillar is glued bricks together, and then it is super glued to the bottom part. But then I can remove the bottom level. It's kind of somewhat inspired by the turtle bot burger. I kind of want a programming platform. So now this comes apart, and these 2 chassis pieces come apart, and you can see there's the motors with encoders on the inside, and the battery charging pack there. I don't know how well you can see that. Maybe I need more light.
Good enough.
But I'll turn on my light here. So yeah, so there's that, and then so it's modular in that way. And then I'll tidy up the wires. I had the wires a little tidier, but I ran into the devil of a problem the other night where I had just had it working, and I went to demo it to the wife and child, and of course one of the motors wouldn't work after I put it back together, and I couldn't figure it out for the life of me. And I had been soldering, but everything looked good, and I wasn't sure, and I basically tore it all apart. Tore every connection out of it and went through it, and I actually had a bad wire. One of my PWM wires for the motor had an intermittent loss in it, and when you put the lid on it,
You pinched it.
Ross,
So-
excellent job. That is the law of demos, and everybody in this group has run into the law of demos. I personally love Legos and have built a lot with Legos, and there's actually a college level PDF on how to build rigid structures, how to make things lock into place. There's a whole philosophy behind it. So if you don't necessarily build that way, they do come apart. You might have to glue them together, but there are ways to do it where, as I say, where you use pins. You use pins and lock things in place. It's the documentation that accompanied the DACTA set, which was the first set that came with motors and pneumatics and all that cool stuff. Anyway, bravo.
I find that with the super glue, you can, if you're not sure on a piece, but you do want it to keep it just from flopping off, like my battery pack is actually glued to a piece of Lego, and then everything else is glued to pieces of Lego, and then they're like kind of, instead of standoffs, they're Legoed on there. But if I want to keep it from just flying off, I might just put like a tiny little drop in one corner there, and it just won't come off. But if you pry at it with a screwdriver, it'll pop off. But if you never want that thing to come off, you could just drown it in super glue, and try to pull a piece off. The plastic around the glue will break before the glue itself will break. So it's actually stronger than the original ABS. Yeah, I see. I'm trying to see David now. Let me see. I'm going to pull that up so I can see what he's showing.
Basically, the technique is you use pins and to lock things in place. So, for example, this piece and this piece have pins that pin into these pieces and lock them in place. And then there's the same thing on the other side to give it rigidity. And this one's, I don't know, 20 years old. I will tell you there is a certain built-in tragedy of Legos, and that is to build the next thing, you have to take apart the last thing, and
or just get a whole mess of Legos.
There you go. Just keep buying more.
I plead guilty, and when I was over at Kareem's a couple of weeks ago, he has those huge crates full of Legos. I mean, it's a Lego wonderland.
Oh, you notice that? Yeah, we've been through a few with first Lego the year.
Yeah, the Lego Technics, I think, is the set, that kind of like beams with the holes through it. I don't know what you call that.
Yeah, they marketed that as a set called DACTA, DACTA. That was the Techniques, and has all those beams and bars, and as opposed to the normal bricks.
Yeah, because they got like, you know, so many thousands and thousands of parts now with the gears and everything, but it's quite expensive actually. If you go to start pricing it out, you know, if you actually, you know, look at something like that and actually try to do it with Technics parts, it's, you know, you're looking at spending a lot on the chassis itself, but a 3D printer would be cheaper.
Once you have a big box of them, though, it really is I found a handy way to prototype things, to test things out. Like I was working on a gripper that bent as it gripped, you know, like a finger does. And that was real easy to fake up with some Legos and just play around with the physics and see how it worked and so forth.
Mm-hmm.
Yeah. Great Lego fit. So don't underestimate the potential of your Lego platform.
I think I eventually want to get this to be some kind of TurtleBot idea with, I think I was showing, I briefly showed a picture of a me-arm type base on the top. I didn't focus on the picture, but I was just fitting it for you know, because I'm not CADing or planning anything. This is just, you know, hey, does this work? Yeah, okay, cool. If not, go back.
I must have missed. Can you show us the bottom of the robot?
Oh, sure. Let's see.
Oh,
Oh, I don't have to share the screen. I can just pick it up and show it to you. We're here. Yeah. So just the bottom just has a skid on the back. Well, a skid on the back. That's actually the only piece of actual brand name Lego on this. Is this skid, and it comes off. That was from my daughter. The rest of it's all the Walmart brand stuff because it's all uniform, so I can get, you know, like a big large chunk of red.
Yes.
But the bottom. Sorry, you wanted to see the bottom, like the.
No, just the bottom.
Yeah.
That's it.
So just a plate. Yeah, I want to put a caster on there or something, but.
That's good. You know, when you have robots that run around in the house, one of the problems is hair. Hair gets wound around the axles, and you have to go in there with like needle nose and pick it out. And
yeah, it does pick up quite a bit. I started.
Oh, you've seen that.
Caster, I put a little duster on the bottom, a little like a Swiffer towel, and I drove it around in circles for a little bit. It picked up stuff that I hadn't seen.
Kind of a do-it-yourself Roomba.
That's right.
Yet another one that's pretty good is Make Block. I've got a bunch of Make Block stuff.
Make Block. It's interesting. Let me get a better view of that.
Yep.
You know, you mentioned TurtleBot a minute ago. If you go on Thingiverse, all of those, almost all of the plates for the Thingy-bot already have STL, so you can print the half plates, the full size plates, and that kind of stuff, and start linking plates together if you want to as well. If you got a 3D printer, I got a couple.
That's my next purchase is the 3D printer. Ray, those wheels that you have on there, the roller skate wheels, are they? Or skateboard wheels?
Yep.
How did you attach those? Like, is there some kind of special?
Makes like a that little aluminum hub in the center.
Yeah.
And they make it for, I think all the way down to 3 or 4 millimeter up to maybe 6. And it actually has, I don't know if you can see them or not, but where's my camera? It's got 3 screws, and it screws to, it's actually 2 parts. The part that you see there and the part that I can't really show you because it's on the inside, but it actually kind of squeezes itself against the, and there's like a raised area on the inside of the wheel, and grabs onto that, you know, is pinched with those 3 screws screwing into the other piece, and then that's, you know, locked onto the hub with 2 set screws. So yeah, those are Make Block motors. You could stick Pololu encoders on them. That's a Raspberry Pi camera.
And Ray, the Make Block parts are aluminum, right? They're not plastic.
Yeah, it's all aluminum.
Isn't that what Murray uses to build his robots?
Say that again.
Isn't that what Murray uses to build his robots?
Yeah, it's either MakeBlock or OSEPT, I think. OSEPP or so I forget how you spell it. OSEP, I think.
I think that's just a metric version of the make block.
Oh, well, they're all the measurements in this are in millimeters, so they're I think the whole spacing is like 16 millimeters apart. They use, I think, M4 nuts and bolts. They have brackets that the motor screws into. Let's see if I can get it up there so you can see those are the two brackets there that hold the motors in the blue. So it's very rigid. I mean, I wouldn't want to step on it, but the frame, once you get all these bolts bolted, like here I could put 4 bolts in each corner. You really don't need it. So 2 kind of locks it in place because you've got, basically 2 at 45 degrees, 1 there and 1 there. And so it once you get it together and you get all the nuts and bolts pretty tight. They also have lock nuts. You can put lock nuts on it. But that was, I think, the challenge line following course is what I was using that one for. I had, a little thing, the 3D printed camera, Raspberry Pi camera holder, Raspberry Pi case. So pretty useful.
Thanks. Yeah, a make block I'm looking at on online right now. It looks really useful. It's all aluminum, you say?
Yep. And they make motors, a couple different sized motors. They make a small gripper. There's all kinds of.
Here, somebody made a laser engraver with make block.
Yeah, and I think they even sell a kit that you can put together with. It's made out of make block.
Oh yeah, make block actually sells this $200 or $300 kit that's got like everything in their pieces and parts and big old. Well, I don't use the word erector set, but erector sets aren't what they used to be. But to put all that stuff together, really cool.
Oh, thanks for putting me onto that. That's going to be something I'm going to look into for my next project because I want something a little more, I don't know, a little less toy-like. But I like the Lego. I don't want to say Lego because Lego Bot's already taken. So the unofficial name for this is something different.
So is Cream up to present something now?
John, you're next on the list.
No, I'm not. I don't know how I got added.
Oh, okay. Alrighty. So my team competed in the regional championship this last weekend. It was not their greatest championship ever. Yeah, the robot just was not ready. We got probably 3-4 more weeks of work to make it, somewhat reliable. And as a result, even it's hard for judges to give awards to a robot that doesn't move properly on the field. And so did not advance to Worlds, but will probably advance to the state championship. And thanks in part to y'all, they got the Connect Award, which is one of the higher awards for connecting with real engineers. And so your time when you entertain them it's very much appreciated. I did want to go ahead and show their Control Award video submission. And so let me do that real quick because it doesn't take too long. Okay, so this is it.
We're Team 6832 Iron Rain, and this is our Control Award video. This year, for a multitude of competitive reasons, we chose a chassis that can extend and contract, as well as a combination differential and swerve drive wheelbase.
To help make the most out of our wheelbase, we researched and developed a vector-based mixer to take in target velocities and convert them into individual wheel velocities and angles visualized here in Desmos. We then implemented these calculations in code. The following equations govern the inverse kinematics of each wheel, given a target linear velocity v and angular velocity omega. The robot's turn radius is shown in green, with the individual wheel velocities recalculating as v and omega vary. We will also adjust to the current robot's length of s.
Using these inverse kinematics, our robot can follow trajectories during autonomous using the Roadrunner library. We created a simulation in FTC dashboard to quickly alter and test auton routines, with little difference between real life and the simulation.
As for vision, we detect the team shipping element position using an OpenCV pipeline that crops, normalizes, blurs, thresholds, and finds contours from the webcam feed. Additionally, we take the average of the last n readings for reliability across disturbances in field setup or lighting conditions.
During teleop, we employ a variety of optimizations and sensors to minimize the amount of driver input. A distance sensor on the gripper allows for automatic intake and transfer of freight. A distance sensor on the bucket allows for automatic scoring of freight when the crane is aligned with the shipping hub.
A distance sensor between the differential and swerve axles allows the robot to maintain a target length, moving the wheels in opposite directions to expand and contract. This is a PID controller, of which several operate on the robot. PID controllers are used to maintain the robot's chassis length, swerve wheel orientation, turret orientation, and path along a trajectory during autonomous.
Oh, that's it.
I love that extension and retraction action. I wonder if you could like lock the wheels so you can make it sort of caterpillar along.
Yeah, we've done that.
All right, inchworm mode.
Inchworm mode. We have that. Yeah, didn't show it. Anyhow, so they've made an awful lot of progress, but just weren't quite where they needed to be to advance. But hopefully they'll get to the state championship in April, and we'll have made a little bit more progress there. That's it.
Yeah. And somebody mentioned Raspberry Pi cameras. I wanted to point out that because they've come out with the version 2 of the camera and I think even a version 3, you can get the 1.3 versions for really cheap now. I bought four of the 1.3 cameras or the 5 megapixel cameras for $14 on Amazon. That's essentially $3.50 per camera. I don't know how long. I guess it depends on when people stop making them and when they run out, when the inventories run out, but they're really cheap. I also blew some money on something I probably don't need because I thought, oh, that looks cool.
Not like any of us do that, you know.
Yeah, it's a bad habit. But I thought, this might be useful at some point. They have a little version 1.3 camera with a focusing mechanism, and it looks very much
autofocus,
very much like it. This is if you need to see something for as close as 5 centimeters away, you can focus on it. The default focus for Raspberry Pi camera is like 1 meter. So if you need to see something closer, you can get one of these. And I think this one was $20. I read there might be some compatibility issues though with the Buster OS. I think somebody claimed that you need to be running a Bullseye to access the motor, the focus motor, which is over I2C.
Oh, it is. That's unusual. So is the connector any different?
No, it's still the standard cable. It's just they're using the Pi cable has an I2C interface on it already, so that's already an option for depending on whether the camera needs it.
Yep.
So speaking of mobile computers, I wanted to ask, and you guys are talking about shopping, have any of you have any experience with a Beagle board or a Beagle Bone Blue?
Nope.
No?
I got friends who have, but I haven't myself.
Oh, he's got one right there. Is that a black? Beagle Born Black? Yeah. How did there's they sell one that's the blue version, which is geared towards robotics specifically, and it has 9-degree IMU and magnetometer, magnometer, built into it. It's got connections for I can't remember how many different motor connections and all that, all with JST plugs. Very interesting board.
I've never done anything with it. I was actually interested in it because it has this neat coprocessor, but it turns out that the that you can use to do hardware I/O. But it turns out that the whole programming environment for that is not ready for prime time. So I've just run a few experiments on it. But it's cute. Look how cute that is.
Cuteness.
Oh, sorry. Is that the Beagle? Is that the AI version or the black version?
This is the black. That's
okay. With the AI, okay, sorry, yeah. There's an AI one too that I wanted to look at. I'm not totally familiar with it.
But it's a testament to what a mess I have here in my shop that I can reach out and grab without moving something I haven't used in 2 years.
I think in that
let us know when you have a yard sale, David.
Hey, that's an idea. I bet you there are so many of us that have hardware that we bought but never used. If we all brought it all together, we could sort of have a swap meet.
That's what my fly fishing club does that every year, and we raise a ton of money.
I have more than that. It used to be the DPRG contest that the winners that they gave us hardware, and which I usually wasn't interested in and never used. So I have a huge box of DPRG prizes,
really?
A servo controller or whatever. Yeah, this is actually from the before time, so they're probably all vintage, 2003. I have a question. It says here that we have 16 participants, but it seems that 3 of them are named Carl Ott. Yeah, I missed the beginning of the meeting, so what has transpired? Carl, are you here?
He had to bail. He said he would just leave the meeting running, and that we'd have to self-manage the queue.
I think he's trying to wean himself out of the presidency slowly.
Who let me in?
I don't know.
He must have set it up to auto
He
accept.
probably did. Is my guess.
It took a long time if that's how it worked.
So
yeah,
he glances at it every so often. Now, in theory, 1 or 2 others could, but
John, I thought you could, and I thought Doug could.
No. Well, that's what I thought, but right now I can't seemingly. So when I log in, it wants to go. Supposedly, there's a path where you go through a calendar or whatnot, but I was running late, so I didn't go through that path.
I don't see Doug here. I don't see Doug here. Is it just off my screen? Doug, are you here?
But
regarding Carl, the reason why he has 3 is that one's used for recording type thing, is I thought, if I remember right.
Yeah, one's this thing, he's watching it, he's got a recording thing, I don't know what the 3rd one is.
Okay, so we have to tell Doug separately about the gold star. Now, Ross, you got a gold star, yes?
Oh.
Isn't that right? What was that?
Yes.
And who else got one?
Isn't he the only one who demoed tonight? Wait. Yeah, I think so.
Yeah. We're a little confused. We could use a president about right now to keep us on the straight and narrow and on target, right?
Here.
Thank you for volunteering, Harold.
Oh, no.
That's what I heard.
Well, everybody
I second the motion.
All in favor, say aye.
All in favor? Aye.
Aye. Well, everybody in the queue is done, so now it's just kind of free for all.
Well, I throw myself in here at the end of the queue. I wasn't able to make the last meeting, but I did watch most of the video.
Oh, look,
The
there's Doug. He's just
And,
joining right now.
Oh, good. And the first thing that I noticed was, okay, I tried to run it at 1.5 speed as was suggested to us. And as Ted wants to be able to do in real time. And it turns out that it was indecipherable as far as I could tell. So if you're just saying, oh, I don't care what Ray has to say, you can zoom past him, but you really can't follow it at that high speed.
I can follow at double speed.
You're a better man than I.
No, just more patient.
But what I had, I was going to make a respond for to some things Chris asked, and I see he's not here, so we'll drop that. And also to Pat, that both of them are in some ways related. And that is both of them were having trouble with some navigation functions. And my experience has been that what you need is a good method of feedback to know how things are working. And there's a couple of ways to do that. But, just letting the thing run around and then, saying, oh, well, it seems like it's getting off. That's just too hard. You need something that's a whole lot more disciplined than that for testing. So as hard as it is, Pat, what I think you need to do based on what you said last week is you got to go out and find a big flat place. It won't be in your house. And the big flat places in the world are things like tennis courts and basketball courts, indoor or outdoor, gymnasiums, big institutional buildings with long hallways and so forth, where you actually have enough room to run some real tests and see what's going on. I saw that Chris has a little square taped out on his floor, but it's way too small. That should be at least probably 10 feet, maybe 3 meters on a side. And you actually don't need to lay out 4 points and have them all be square and everything. All you need is the starting point. So lay down an X, get some painter's tape or something, and lay down an X and find a way that you can repeatedly put your robot on top of that X in the same position. What I do is I line up the axles of the wheels on the back and forth piece of tape right in the middle, and then I line up, there's a bolt sticking out right in the front of my robot, and there's a bolt in the back, and I line those up. So you scoot the thing around so that you can repeatedly put it back on the same point. And then you need to run a square, not just a straight line, in order to see what the robot is really doing. Now, I want to back up a step. You were talking last week about these problems being solvable with a IMU or a rate gyro, and that's absolutely true. However, I will say just for me that when I build a robot, I always get just the straight wheel odometry working as well as I can, because there's other cool things you can do with that. Before I then stick in the gyro or a IMU or whatever that's going to really give me accurate readings. So I think what you're doing, trying to get that to work is at least is the way I would do it. So I want to take a moment and describe how a Borenstein square, how that calibration works. I know a lot of people in here have done that, and it's actually one of our competitions. But basically what you're going to do, you set this up on this X and you tell it, I want you to drive 3 meters in a straight line straight ahead to the best of your ability. And then you actually don't have to turn 90 degrees. That's an easy way to do it. But if you just have a waypoint list that has 4 waypoints in it that are in a square, one straight out in front of you, one to the right of that, one south of that, and one back to the starting point. You don't have to rotate around to your original orientation. When you get to the starting point, just stop. And then you need to measure the distance between the center of the robot and the center of the X that you put down. And on my robot, there's different ways to do that, but I actually have, on RCAT, I actually have a hole right in the center between the 2 wheels. And I look down through that hole when it stopped, and I slide a dime in underneath it. And then I move the robot, and I use a ruler or a yardstick, or however bad your error is, to measure the distance. And I do it in 1/4 inches. It doesn't really need to be any better than that. So what you're going to do is you're going to drive that square several times clockwise. So when you get back to the starting point, you're going to measure the error in X and Y and record that. Bornstein suggests that you need to do it at least 5 times because there's a random error in your test. And one of those times might hit the target right on, right? So if that's the only one you did, you'd say, hey, it's calibrated. Once you've done that, you need to go around in the opposite direction. So turn the robot 90 degrees and run the same test, but this time counterclockwise. Now, my robots I have in the navigation code, I have a switch I can throw that just reverses one or the other of the coordinates. So going left hand and going right hand is just a matter of throwing that switch rather than having a different waypoint list. But however you do it doesn't really matter. Now here's the truth. You could actually drive it around by hand, right? That is, if you have a remote, you don't really need to have the robot do it. What you're checking out is the odometry, not the navigation. So when you drive it around by hand, in that case, you'd go back exactly to be on the X, but your odometry would say, oh, we're off by 5 inches this way and 3 inches that way. And that becomes your error. So you don't, and furthermore, you don't really have to drive a perfect square by any means. You could actually drive a circle, but you have to do that same thing in both directions. Okay, if there is an error in your wheelbase value, the constant that is your wheelbase, that you're dividing the difference between the two wheels in order to come up with your angles, then that will show up as a symmetrical error. That is, whether you're going clockwise or counterclockwise, you'll overshoot by the same amount or undershoot by the same amount. But if one wheel is slightly larger than the other, and they always are, then what you'll see is that the errors are asymmetrical. When you look at, basically you're going to take the 5 runs that you did and plot the center and use that as kind of the average return point. And if their wheels are not the same size, then those 2 errors will be asymmetrical. One will overshoot on one side and the other one will undershoot or something like that, but they won't be the same. And that tells you a couple of things. If in point of fact, your wheels are really too fat and you're not rotating around the same point, that should still be the same in either direction, right? The error should be the same in either direction. Remember, we're not mixing a bunch of left and right turns here. We're turning always right or always left. So you can separate those out. So there's actually 2 separate errors that this test demonstrates. And one of them is whether or not your wheelbase value is correct. That is, are you overshooting or undershooting? And the other is whether your 2 wheels are actually the same size or not. And as I say, they never are, even with really good high precision wheels. Then the last one is a really good test, just to run, just quick and dirty test, is to do what you did and have a singular starting waypoint, a waypoint you're going to, and you return to the starting waypoint. And then just let that run repeatedly. So you can watch the error build up. If it begins to slowly rotate, which is probably what it'll do, after say, 10 runs back and forth, you can see that real quickly, and you can know that you have to do the more disciplined test. I was going to say basically the same thing to Chris. With all his cardboard boxes, it's hard to tell what his robot is doing. He should drive in a straight line out to a waypoint and drive straight back, and then put a cardboard box in there and see what it does to get around that singular obstacle, where you can really uncover what the robot is doing. I think that's it.
Well, thank you very much for that info, David.
I actually,
This is where you can get some sandpaper and sand off that wheel.
I actually have a paper, Pat. I don't know if you've seen it, where I go through that process. Let me see if I can find the link, and I'll.
Yeah, I don't think I've seen that. And do you go about how to correct it? So if you are out 2 inches all the time, let's say.
Well, let me present. Present now. Present now. Are you not going to let me present? Doesn't it usually like bring up a screen or something? Ah, okay. Let's see. Can you guys see that?
Yeah.
Okay. I'll just run just outline this, Pat, and you can go back and read it, but I'll put the link in the chat once I get back over there. But basically, here's the algorithm, and in the constants that you have to adjust are this left clicks per inch and right clicks per inch. And it tells how to get that. And then the wheelbase and how to measure that. And then I go over, I think the question you're asking is, how do you correct for those? And if you actually look at Borenstein's paper, he has a laborious way of doing it mathematically, but I've found that it's much easier to do it cut and try. It's a lot like sighting in a rifle scope if you've ever done that. So you fire a pattern and you take the middle, and then you adjust elevation and windage, and you fire another pattern and take the window and so forth. And it converges pretty quickly. And if I can't find it in here, but in each case, I actually tell you, like here, for calibration, making the wheel size error makes the robot turn more negative. And down here, making the wheelbase smaller makes the turns looser, and bigger makes them tighter. And then I actually run a set. These are so small, I don't know if you can see it. Can you guys see these little red?
Yeah, we can see the dots.
Okay. This is the red dots are the arrival for, I think I did 7 runs or 9 runs. So it started at 0, 0, which is right here. And it did this basically 40-foot square. And these are where the arrivals were. And then I did the same thing and I went counterclockwise, and here's where those arrivals were. Well, looking at this, you can tell a couple of things. Let's see, I even think I won't have to go into it because I wrote all that down here. But I told what values I used and what corrections I make. And you can see here for the second set of runs now, they're more or less symmetrical, but they're both overshooting. So I reduced the wheelbase. And for the last set of runs, you can see that some of them actually hit the center, but they're all kind of randomly scattered around the center, which is as best you can do. You either have to be a better robot builder or have a flatter floor or something.
What's your grid size on your on that graph? Out of curiosity, is that like 1-inch grid, or is that a?
Let's see. Each one of them are different because they get better as we go along.
Okay.
So here the grid is a -6 inches to +4 inches this way, and -6 to +4 this way. And here the grid is 3 inches to -3 inches both ways. And here the grid is 1.5 to -1.5 both ways. So all of the points here after going a 40-foot square are within about a 1/2 inch of the target. There's a few outliers. And so, okay, I said I'd paste this in. So I got to go back here, stop presenting.
Living in a small town, it's tough to get a big, wide, flat surface. We don't have a university.
There's bound to be some meeting hall somewhere, or
yeah, a little tough in COVID days to get in there, but I can see what I can do to try to get in there. I
You
can
don't
see
have
where he's
parking
saying,
lots?
we do.
they're covered with ice and snow, though.
Yeah.
Exactly.
Hey, wait till summer.
You know, as long as you're not making a lot of noise, maybe a library. They might have some wide, flat spots to mess with there. If somebody doesn't, play soccer.
They might have a meeting room, a library meeting room.
We have a rec center with a couple different things here, so I may inquire and see if I can get in there.
My experience has been when you show up with a robot and say, I need to run a test and it'll be quiet, that people will go, oh, robot, oh, cool. Oh, he's got a robot. He's going to run.
And it's no longer quiet.
Yeah,
just
so
wanted
we've
to.
got an arena, and there's a big, it's a 150-foot by 75-foot meeting room in there and stuff, so I may be able to get that.
And a hard floor, a tile floor, is preferable to a carpet. Also, if you happen to be in a nice big institutional building like I work in, they have those standard 1-foot square tiles. So the floor is this enormous piece of graph paper. You don't have to put down any tape or anything. If you want to go 50 feet, you go 50 tiles. It's great.
So what I'm finding with the robot is my X and Y as far as going out. So I have it go out 617 centimeters. And when I check that, I'm within 1/8 of an inch as I go out.
That sounds good.
That's pretty. The reason I'm laughing is because you tell me you go out a number of centimeters and you're within an eighth of an inch. It's
Yeah.
just so
I go out about
thing
16
going on
feet.
here.
Welcome to Canada.
Welcome to Canada. Yeah. I go miles per hour, but I buy in liters. So
Oh,
that's what happens when you grow up in the 70s and they confused you.
Well, Pat, let me ask this. I saw your plot from last week, but I'm not real clear on the algorithm you're using. So, there's two different ways you could drive to a waypoint 16 feet away and turn around and come back and try to make it back to the starting point. And one way is that you could point your robot at your location, and then you could tell the robot, to the best of your ability, go in a straight line for 16 feet. And then when you get there, rotate 180 degrees to the best of your ability, and then drive backwards 16 feet and see where you land. In that case, you're incredibly sensitive to that rotate 180 degrees. The other way of doing it is to navigate toward the waypoint. So you're correcting in real time with every sample. And my understanding is that's the way you're doing it. Is that right?
Yes, that is correct. So I tell it to go to 617,0. So go straight ahead for 617 centimeters. And then I change my target to say, go back to 0, 0. So the robot turns whatever way is the shortest, left or right, spins around and goes back. The problem the best I'm getting is I'm about 2 inches away.
But at this point, you're going over that bumpy tile floor. So
That's probably not bad.
you need to be able to really know what the robot is doing. You need to have a knife. What you want to do is make that the best possible test case.
Okay.
So that you'll know, I can't do any better than this. I can't blame the floor or anything else. This is the best case. And then obviously, well, I shouldn't say obviously. What I've found is that once you add a rate gyro or an IMU, it totally changes what you're doing, because the wheel odometry itself depends on contact with the floor. So with a IMU or a gyroscope, you can actually pick the robot up real quickly, rotate it 90 degrees and put it back down, and it'll turn back around and go where it was headed. It knows which way it's going. And
I noticed that when I tried to correct it.
Yeah, it can be annoying. And by the same token, each time you hit a little bump or a little hole in the asphalt or whatever, it's doing the same thing. It's wiggling that heading back and forth. And so your best case scenario on a beautiful floor, really starts to fall apart when the surface is really rough. But the gyro or the IMU totally takes care of that problem, because they know that you really, wiggled back and forth a certain amount. When I was saying that it was useful to have the wheel odometry also, I think I talked before about how you can, even though you're not using the distance, the angle calculated from the wheels. You're only using the distance. You're getting the angle from the IMU or the gyroscope. Even though that's the case, you can compare the two of them, and they should most of the time be pretty close to the same. That is, what the wheels are saying and what the gyro are saying will not be exactly the same. And if you integrate them, they'll drift apart. But they should instantaneously be about the same most of the time. So if they're real different, that tells you have an air conditioner. Your wheels are slipping or you're stuck or something like that, especially if the wheels say, I'm turning, and the gyroscope says, no, you're not. Then that can be used as this separate piece of information to tell you need to change your behavior because you appear to be stuck. Same thing if you're shoved sideways, the wheels will say we didn't turn, the gyroscope will say we did.
Yeah, so one of my problems is I'm having trouble lining up my gyro reading with the motor odometry. So when I see a deflection, where is it in both cases? And what I think I need to do is one of your tricks where you put a speed bump under one wheel, and then I should be able to spot how much of a delay there is between the one versus the other sensor. Because my IMU is tied directly to the Raspberry Pi, and my odometry is coming through a serial port from my Arduino.
Now you don't have the 200 millisecond latency that Chris says he has, do you?
No.
Okay.
So, what I did notice is quite a few zeros coming back, or none readings coming back on the BNO. So if I read a none, I put the value through as 0, just for lack of not getting a fault. I say, hey, if the value comes back as none, make it 0.0.
I'd have to think about that. You might want to say make it whatever it was last time.
Yeah, make it the previous value.
Yeah, let me think about that a little bit. The
I
my
can't make it the
experience
next value, but
when trying to add a rate gyro a direction from the IMU, I have a CH Robotics CR6 IMU, and what I found was that the heading, the IMU heading, which basically you're reading back Euler angles, so that's a yaw. That the yaw was delayed in time behind what my wheel encoders told me the actual angle was, and that was enough to keep it from working. So what I did on almost any IMU, there's a way you can tell it what data packets you want, what information you want. So what I told that IMU was, what I want is the raw z-axis gyro, and it can give you that. Now it's actually not raw; it's already had the drift subtracted. They call that the cooked gyro. So, and it is, I sample that 25 times a second, and it is accurate to within less than 1% of what the wheels say. Also, in order to make that translation, the IMU is actually returning me degrees per second, and what I need is radians per 25th a second. So I have to convert that to radians and divide by 25 to get the actual number that the wheels are returning.
And that's what I was wondering is with the BNO 055, is it returning radians per second? Does anyone know in the list?
Degrees.
It's degrees per second?
Because degrees.
It's returning a very small number.
It's
0.001.
Well, that could be your if your heading is, I want to say it's a real on mine. I don't even use it as a rate. I just whatever it is, and go off of it. I believe if you look it up, it'll be degrees. Otherwise, the heading is a degree value. It's not a rate.
I'm not using the heading. I'm just using the gyro, the yaw. So the z-axis on the gyro.
Why are you integrating it yourself?
Yeah, I'm not sure. That seems like a mistake.
Now, when you say you're using the rate gyro, you're using the yaw. Those are two different things. Yaw is an actual heading that's returned by the IMU based on a bunch of things. But a rate gyro only tells you how much the gyro has rotated in the last whatever sample time you're using. So it's as it says at the gyro. The gyro tells you the rate, not the heading. So you have to integrate it yourself in order to know the heading.
Yeah. So the BNO it's definitely degrees, because I'm just using heading.
Yeah.
Just because the heading is in degrees doesn't mean that the rate gyro would be in degrees.
In fact, it's actually it's between 180 and minus 180. That's the way it's returned. So it's not even in 360.
Okay, well, that's not what a rate gyro returns. A rate gyro does not return degrees. It returns degrees per second.
Yeah.
Right.
That's what I'm using is the rate gyro.
And I'm saying is I don't use that. I use, God, I can't think of what mode it is. Kareem, maybe you can tell me. It's NOF, 9 degrees of freedom, or no, it's not 9.
There's a couple of different names they use, and it depends.
Yeah. I think it's just called the IMU mode.
Yeah.
As opposed to the 9.
That's the one without the magnetometers.
Right. It's the one without the magnetometer, but it still goes through the.
Which is the default mode, I think.
I think that's right.
Yeah.
I think the 9 isn't with the magnetometer default.
I don't know. We always use it.
Anyway, yeah. So but I just use the. So you're using the rate. You're actually using the gyros and the accelerometers.
No, I'm wondering why Pat is using the rate gyro
I don't,
instead of the calculated heading.
Well, the reason I used it, I'm not sure why Pat's doing it, is because, as I mentioned, the calculated heading was behind, considerably behind
Sure.
where the robot actually was. And so to combine that with how far the wheels had turned, which you're getting from the odometry, did not give an accurate location.
We don't see. I've never seen a lag between from the B&O 55.
Yeah.
No, I'm not saying the B&O 55 is the lag. My Arduino is the lag.
Yeah.
So I've got about a 40 millisecond lag. I've got two readings lag basically on when I send an action to the Arduino and when I receive an input back.
Well, as I learned from Doug Parody, if you're just going to use a gyro, you have to sample it really, really, really high, and then average those things together because they're all over the place. So you sample at a much higher rate than what you need, and then average down to the rate that you need.
And that's why that's the reason why I suggest not just using the heading, because all of that is handled by the B&O 055. You're not even having, you're not having to worry about the fact that it's reading something 250,000 times a second or something like that. You don't have to worry about it. It's all being done for you.
You can't do it better than the B&O 55
Right.
does it.
Well,
internally.
and as you say, basically, what reason I was using the Z-axis rate gyro on the robot I'm running is because that particular IMU sucks.
Yeah. Well, it could also be too. I mean, you came from you did a lot of helicopter work in between sometime, and that they use rate gyro, to keep it from spinning and all of that stuff.
But the modern helicopters use what they call a heading hold gyro, which is basically what we're talking about. IMU.
Yeah. Okay. Hey, I'm gonna post something you might as an alternative. Here's a UMB Mark YouTube video that's really good. I mean, it's more formal than I would do it, because I'd probably do it just with a little black pieces of tape. But this one's really good if you want to see somebody who's kind of seriously going after it. I mean, I recommend it, but everything David told you will do everything you need to do. But this guy, he's got graph paper on the ground and marking dots and all sorts of weird stuff. Yeah.
Well, everything will help. Like I say, the whole point of this isn't for my robot running around in the house. The whole point of this is for working on my outdoor competition stuff.
And I think what David told you earlier too is, everybody gave you the advice last week because you were having to run on that tile floor. The answer is like what Dave said, is don't run on a tile floor to do your testing. Because, I mean, if you're going to do testing on a tile floor, you got to have an IMU, because that's the only way you can go. But I mean, it will tell you and then you got to ask yourself, well, hey, wait a minute. If I use the IMU and it covers up all these sins and it just works, should I worry about it beyond that point? But
well, that's what I'm thinking.
How far is 117 centimeters?
Or 617 centimeters is about 16 feet.
16 feet, and you're turning around and coming back.
And I'm turning around. Well, originally I was doing 300 centimeters, so about 10 feet. And so I go out 10 feet, turn around, and come back. And
how far?
When I did that, I was out about 2 inches.
You should be able to do better than that.
So
on that, if you were on like a hardwood floor, you would do better than that.
That's still way better than you're going to need outside.
Oh yes, outside. That's fantastic.
Well, the reason I want is that I don't think that the odometry will work as well outdoors. I need the IMU, I believe, with all the bumps on the ground and everything else.
That's exactly why you don't need your odometry to be as tuned.
Yeah.
But the
other hand, it's useful. It's useful.
It never hurts. I'm not saying you shouldn't
and I would say also too that it's the angle that always gets screwed up. It's not the distance usually. I mean, you'll get out there, you might find that you can, go 100 yards and you'll be within, probably not a hat trick like Dave did, but, you could probably be within a 10-foot circle. And I mean, if just driving 100 yards with your odometry.
Well, that's the thing. When I look at my odometry and I plot my odometry, hey, I'm doing good. I'm coming back right to 0, 0. I'm within a couple millimeters is where it thinks it is.
But there's actually two problems, and sometimes they get mixed up together, which is that the odometry itself is a sensor, right? And the behavior that's using that sensor is the navigation. Yep. So the odometry could be spot on and the navigation not be very good. Those are two separate and distinct problems. And there are a lot of people in this group can tell you about having, perfect sensors and still not being able to get to the play point. It's not the sensor's problem, it's the ability to use that information to drive and not to overdrive and not to oversteer or understeer and not to, navigation is a separate and distinct problem from accurately knowing your location.
I'm still looking for that perfect sensor.
Doug, we had a gold star tonight, and it was Ross, who showed us his Lego robot, which is a fine example of the genre.
His Playday robot.
Playday, yeah. I had a question about IMUs since we're on the topic. Now
we're always on the topic.
Fair enough. I have a couple of IMUs kicking around that are just these little 6 degrees of 6 DOF sensors, like they're 3 degree, and then like this one here I have here in front of me, it's a MPU 6050, and you're probably familiar with them, but they're 3-axis accelerometer, 3-axis gyroscope, and a digital motion processor.
That can be that sensor can be
used anything, or do you need a 9 degree IMU to really be useful? Because you're not measuring, you're not getting any magnetic heading here, and you're not getting.
We're not even using it. So
no,
your 6 degrees is fine, Ross. There are some available on Amazon from China now that use that sensor, but they also add in a Kalman filter onto it, and they're about $20. So using that raw sensor like that is probably good for something like a balancing robot, or if you want to have a gimbal where you're pan and tilting, okay? Mm-hmm. But if you want it for navigation, you probably want one with that. I mean, you can do the Kalman filter yourself, but why do it when somebody else is going to build it into the module, do it 10 times better than you're going to do it, and it costs you $20.
There's a whole foo of Kalman filters, and there are people who eat and sleep that stuff, and you should pay them.
And are they? Sorry, the name. Sorry, could you say the name again?
Kalman filter.
Kalman.
Yeah, and actually what these use is what's called an extended Kalman filter. Basically what you do is you build a model of what you're trying to control, and then you measure the error between what the controls do and what the model expected, and you correct the model. And that all happens in real time. So for example, with a PID controller that's all tuned up to move a robot arm, now you pick up a 50-pound weight, you've detuned the PID controller because the arm is now heavier. But a Kalman filter will fix that. It'll adjust the model to fit the feedback that it's getting. But there's a whole lot of involved, and you end up with these big matrices of numbers that mean nothing to human beings. And there's a whole witchcraft of Kalman filters. And as I say, there are people who eat and sleep this and will sell you their products for $20. So.
Sure. Yeah. Well worth it. I'm sure it's like, less than a price of going to a restaurant. So
I would just
treat yourself to a Kalman filter and be done with it.
Exactly. Have to. And I would expand a little on what Doug said, that basically what you get when you go to 9 axis, when you have 6 axis, then where your grid is aligned is arbitrary. So for my robots, it's wherever the robot comes out of reset. It's at 0, 0, and it's pointed along, 0 heading. But once you go to 9-axis, you have real live north. So you don't have an arbitrary grid anymore. It's actually offset from north. And in that case, when I hit the robot comes out of reset, it calculates that offset from north. It's still sitting on the grid wherever I set it down, but it says, but this is 17 degrees off of true north. So that's the huge difference. Murray always wanted a robot that could go from the front of his house to the back of his house, and he was convinced that he needs a compass to do that. For some reason, he couldn't be convinced to just point the robot toward the back of the house and let that be the alignment. But for outdoor things, you do want to know where true north is, especially if you're going to use map coordinates to try to move around. So that becomes real important to have that. Also, the magnetometer works outdoors, and it doesn't work for shit indoors. You got metal pipes and refrigerators, and it can swing 90 degrees from where true north is as you drive around. So
rebar and concrete.
Essentially, a Kalman filter, if I understand it, is it basically what gives you takes the raw gyro inputs and gives you essentially a static model that you could use for like the accelerometer on an airplane that it's a non-magnetic compass. You set it at their flight, and then you always know which way. Is that basically how you would use the Kalman filter? Is that how mathematically it works?
One way to think about it is that the different sensors that you are using have different error. So, for example, you can think about the gyroscope is real good at telling you instantaneously how the robot is doing, instantaneously how it's rotating. But if you integrate that value over a long period of time, it's not really very accurate at telling you which direction the robot is pointing.
It'll drift.
Yeah. An accelerometer can tell you where down is and can do that reliably. It won't drift over a period of time. So if you have a gyroscope that's on the same co-axis, you can use that accelerometer to correct the drift in the gyro. Because basically you have a very long-term average that's not reliable short-term, and a very short-term average that's not reliable long-term. And the Kalman filter says, all you got to do is tell me how much to trust these things, and I'll work out what the real direction is. And further, you just tell it where to trust it initially. It corrects that on the fly as it runs. So it's not like it builds a static data structure that you use somewhere else, but rather on the fly, it rebuilds its own coefficients to match what it's actually seeing. So basically, it's a way of taking sensors that are noisy and imperfect, but in different ways, and using them to fill in each other's gaps, if you will.
Thank you, Doug, for the link. I'll check it out.
Generally, the Kalman filter that's built into these things is not something you have access to. You don't have access to the model. You just have access to the output of it.
Mm-hmm. Yeah. And if you're using a raw 6050, if you go to the company that makes the chip, they have some sort of filter that they'll give it to you in a form of, I think, of assembly code or something, but for the chip, but it still works, but it's a little more complicated. Now, I'm not saying that Wit Motion, I guess that's how you'd say it, they have a whole line of IMUs, and I bought one to try out. But my go-to right now is still the BN0055. Okay, but I'm trying out one of theirs to see if might be good for indoor robots. They also do a 9 degree of freedom for outdoors. They also do, and here you have to check. If you go to their website, they have some that will integrate with a GPS and some that don't. The one I just posted doesn't, but the same sensor with the ability to do the GPS is also available, but it's only in a chip form and it doesn't have a package. So, I mean,
And there are
Interesting company. It's pretty new, I think.
there are a lot of them out there that can interface with the GPS. And again, you're hooking up to a sensor that that can't give you very good local. You couldn't really you can navigate with the GPS, but you can't maneuver. It can't tell you which way you're headed 40 times a second or whatever. But when it's the Kalman filter has it as another input, then you get the best of both worlds there. You get this real high resolution signal you can use for maneuvering as well as a long-term trustable navigation value. I will add that the BNO 55, I think most of the people here use, they turn off that they're using it as a 6-axis. They turn off the magnetometers.
Yeah. Well, I'm not sure if I would on the outdoors, but right now you're right, Dave. I'm running it with 6. But the other thing that this company has is they call it military grade IMUs. So I don't know if there really is anything to it, but they do make that claim. They're out of China, and they have gone up $10 since in the last couple of months.
Ooh.
I mean, I used to be able to get this module I just showed you for $20, and now it's $30.
Plus, it encrypts all your data and ships it back to China.
Right.
It's got a little camera on it, probably.
Yeah.
Allegedly.
Did anybody see there was a KERA special on gravity waves? Kind of makes me wonder how stable our little IMUs are. If you assume gravity is constant, and then they make this huge instrument out in the desert, and I think New Mexico, to basically detect gravity waves. So I wonder how often we're actually being hit by gravity waves. I guess it's from
It's
black
constant, but it's so tiny you couldn't imagine.
I was going to say I have some
extremely small.
But the seismologists I work with have to take those into account when they look at the spreading of seismic waves. So that's part of their equations.
Really?
You're talking about two different things. I think Ray's talking about detecting like gravity waves from black holes collapse or
combining
neutron stars colliding, that kind of stuff.
But it's the same thing. The gravity waves are spread around the Earth by things like earthquakes and volcanoes and so forth. So
yeah, those are way bigger. Those are huge compared to the things that the what's it called? LIGO? The LIGO experiment is detecting.
Yeah, LIGO experiment. That's exactly the name I was searching for.
Believe it or not, I have a little history there. I went to Louisiana State University back in the early 80s, and I was a lab assistant in what I call a gravity wave lab, the kind of the precursor to the LIGO experiment. That was Dr. Hamilton was the professor running the project. They had a 6-ton cylindrical aluminum bar.
I remember hearing about that.
Yeah, and it was supported by 4 titanium steel rods about as big as my little finger each. Through each one of those rods through a vibration isolation stack, because they had to essentially isolate all vibrations from the outside world, and then all of this is inside of multiple cylindrical aluminum shells. And each shell around the aluminum bar was they had to cool the thing down to fractions of a degree Kelvin to eliminate the thermal noise. So that's why they had multiple shells for multiple degrees of cooling. Of course, it was evacuated with vacuum pumps, and the detector at the end of the bar. The idea was, as a gravity wave passed through the bar, that the bar would oscillate as the wave passed through. So they had a finely polished plate at one end of the bar, and 2 finely polished plates, one on a detector and one mounted to the bar. And that formed a little microwave gap, and they could measure the distance between the plates down to somewhere close. The average distance between the plates could be measured down to somewhere around the order of the diameter of an atom. It was that precise.
And it wasn't precise enough.
No, it wasn't. That's it. They didn't.
LIGO can do it down to like down below around the size of a nucleus.
Yeah.
Well,
that's science for you. Even a failure shows you something, right?
That's
yes,
right.
but imagine writing the contract, writing the grant for that. You want to do what?
Exactly. I would never have believed it until I heard a real detailed explanation of how LIGO works, and it's still amazing.
I have fond memories of that. I remember the lead technician in the lab, they had to tune the Q of the whole mechanical assembly, the quality of the ring down time. Basically, they needed to measure how much time an induced oscillation would take to fade to measure the effectiveness of the vibration isolation stack. And the method they used is, the guy's name was Alan Sibley. He would get up on top of that big container with a big rubber mallet and whack, and he would hit the thing as hard as he could with his big mallet, and they'd have an oscilloscope, and they'd watch the oscillations ring down to the oscilloscope. Okay, hit it again. Whack.
What was his name?
Alan Sibley was the name of the technician. Oh, you mean the professor?
So this
Dr. Hamilton.
So this is a sibling unit. One sibling unit.
I guess so, yeah. Yeah, that's I like to call it the lab, the Louisiana State University Center of Gravity. Oh, we had all sorts of fun down there playing with liquid nitrogen too, you know.
When they take the geophysics students out to do field work, one of the things they do is they set up an array of seismometers, and then they just hit the ground with sledgehammers so they can look and see this big signals and see how it changes in whatever direction it propagates and everything. But one of the things they see is after a while, once you get used to looking to the signals, you don't need the sledgehammer. You can see yourself walking around. You know, you can see little tiny signals. The sledgehammer is just to get their attention.
Yeah, I used to have a friend of mine that was his job. He went out to Alpine and got him a geology degree, and what he used that degree to do was basically work for one of the oil companies around here. And he loved being in the outdoors and camping and whatever else. And they would have him go out there and set seismic charges and do the testing in the middle of nowhere, and it was right up his alley.
Oh yeah, I've been on one of those crews on a summer job as I was cutting brush. They had 3 teams. The first team cuts the brush. The second team lays out the cable. And the third team plants the charges for the truck.
Yeah, he'd tell me a couple stories, and he says, something wouldn't work right, and you have to reshoot everything, and you'd come to find out, something chewed through one of the wires, or he didn't pack it right, so you got a big blowout, and you didn't have anywhere to run necessarily, so you're about to get a bunch of crap just falling down on your head. He had a lot of fun stories like that. Yeah, right up his thing, right up his alley.
I can tell you that, having been on some of those outings myself, that despite all the warnings and the sirens and everything, it's still always kind of shocking when the explosion goes off. You're never ready for it. But when you push the button yourself, that is so satisfying.
I bet so.
We did a presentation to a whole group of industrial miners in Las Vegas one time, and started off with a video of blowing out the side of this mountain. So it's, sequential charges, hundreds of them. And about halfway, these guys all in their business suits, right? It's a big conference. About halfway through the video, when you're just seeing the front of this mountain just blasted loose and flying off into the pit below, somebody in the back of the crowd cried out, "Go, baby, go!" And I thought, well, these guys in all their serious suits and all their equations and everything, but they just like to blow things up.
Yeah, they do. Yeah, they do.
I think we've wandered sufficiently off of robotics.
Yeah, I do.
Yeah, well, nobody's got anything left, I don't think.
I have a couple of things if you want. You might have seen that note I sent out to the DPRG about Raspberry Pis.
Yeah.
I've been having a hard time. Luckily, I found the Pi 400 is exactly what I needed at Micro Center, but they haven't had any for a while. And the people say we get Pi 400s and we get Picos in, but we don't get anything else, or not a lot of it. And so I went and looked at Mauser, and Mauser's not expecting. They're expecting a bunch of them come May 12th. Set your calendars. Wake up early. I don't know, alarm, whatever that is, if you really want those things.
Yeah, I've seen several posts about that on Facebook about the availability of Raspberry Pis, and somebody was complaining about the cost of people jacking the cost up for the Pi 4 on Amazon to over $200.
Yeah, I went and looked too. Almost all of them are over $200. Even a Pi 3, you can't find those very much anymore. And even a Pi 3 that was $35, people are wanting over $100 for.
I think the key here was that if you were willing to wait, you can pay the normal price. It's just people are kind of gouging at those people who need a Raspberry Pi right now.
So the compute modules seem, I think they were especially hard to get a hold of, especially if you bake these things into a product, because that's what they're meant to do with the compute modules. Bake them into a product, and you need to go get a supply. That's the problem. And the other thing, did everybody? Well, Murray's not here, but everybody see the 3D printer thing I printed? I sent out through there. That link, it's in store only, much like the SSD drives were a few months ago. If you're a new customer or know somebody who can be a new customer, you can get you an Ender 3 Pro if they have stock left. And I was in there. I was in our local Micro Center, and they had a good number of them left on that for $100. It's $100 off a $200 printer.
Yeah, that was the same post where you noted that they ran out of PLA.
They ran out of PLA. I mean, I looked in there, and there ain't no PLA nowhere. There's plenty of ABS and there's plenty of other things, but there ain't no PLA nowhere. Not in the back. Usually, if you want black or white, because they usually stock so much of it, they'll have that in the back, and you'll need to ask them for white or black or whatever. But they didn't have any of that. It's all gone, all gone. I was kind of surprised.
Yeah, that's the day was the great post for people putting in good stuff in the links. I wanted to ask if anybody taken a look at what Green put out about the phased arrays, and the guy building.
I had a chance.
Well, I tell you what, that definitely is a go look at video. Make sure, and since the guy's basically open sourced it, I believe you can get the board and everything.
Yeah, we mentioned that earlier, and I was pointing out that it's a neat project, but it kind of looks like it might not be practical for a mobile robot because his frame rate is kind of low.
Yeah, I see what you're saying, because I think most ultrasonics that we use have a 39 millisecond cycle. So on the phase array, he's triggering them all at the same time.
Right, but see, he has to steer the beam each time, though.
Yeah.
Right. So it's a question of how many times does he steer the beam in one cycle before he can repeat a cycle, and there's a lot of math that I'm sure that factors into it. Mm-hmm. But in his example that I saw at the very end, it looked like his frame rate was fairly low.
Okay, that's a good point. Yeah, he did. I think he did mention that it was low, but he said he was quote working on it. So, but that's it is something that we probably could apply to something else if we thought about it somehow. Anyway, it's kind of cool. I really thought
do it with
everybody
light pulses if you can get the timing really short.
Yeah. Well, no, but the other thing was the MayPi link. Other people may have been aware that I knew they gave out free magazines, but I didn't realize that they had, it went back that far. So anyway, it's cool.
Well, I have a comment about that high-speed line follower I think Murray posted, which is that if you go back and look at it, where the lines are big and swoopy and easy to read, they're just lines. But whenever they move rapidly, there are tape markers that point normal to the curve on the inside of each curve. So that's not just a line follower. It's impressive, but it's not a line follower. It's getting more information. Go back and look at it. Each time there's a small curve, there are tape markers on the inside of the curve that show you what normal to the curve is at two different places as it turns. So that seems like cheating, doesn't it?
Yeah. Well, I'm sure everybody's seen the Hong Kong line followers that are whipping around at the speed of light, and they all they've evolved sort of like sumo, in that they found the winning combination. So there's not a whole lot of variation between all of the racers. They all look the same. The same thing with RC cars. They all look the same. They all got the same parts, but it's still pretty amazing line following. Yeah.
Well, maybe they just found the optimum design with the available off-the-shelf parts.
Yeah, but it's totally different than how typically we do a line following. We probably do line following with, they're all camera based. They're all have a staff on the top, and they're looking forward, way forward. But they're not doing sharp turns per se. They're doing kind of loopy turns, but they do have a lot of intersections that they have to interpret. And I don't know if they just drive. Maybe it's just you always go through the intersection. I don't know. So, but it's kind of cool to watch.
John, this is something we've talked about before in the group, that is sort of a conundrum of robot contest, which is that we always think we're going to have a contest because the idea is this is going to lead toward a general purpose robot. That's the idea. We're going to just test this certain thing or this certain thing. But what actually happens over the years is that it doesn't lead toward a more general purpose robot. It leads towards a more and more special purpose robot that can only run that contest and do nothing else, and can't even be turned on if it's not on the contest course. So it's kind of hard to argue that these contests lead us to more generalized robots. It seems like the opposite is true.
But they are a skill builder. So that's the thing, that each contest builds on the next one up.
I would use a musical analogy, that they're like scales and arpeggios for those of you who've learned to play a musical instrument, except that when you learn scales and arpeggios, the end result is not to give a recital of scales and arpeggios.
I assume a lot of these designs, any complicated design is a whole series of trade-offs. And if you have a specific goal, then you have to sacrifice, you can't make it a general purpose robot, I think is what you're saying, David, because you will sacrifice all of the non-important goals for the ones that win the contest.
Mm-hmm. Yeah. And I like I say, I look at them as builders. First of all, the first one is usually is forward and backwards. You go out a certain distance and you have to come back. That's the first contest. So you learn how to drive and turn. Well, you learn to go forward and to go backwards. You don't necessarily have to turn. The rules don't say you have to turn.
But you've solved a huge number of problems. You actually have a functional base.
Right.
You control that base. You have a software environment where you can develop code. You can download that code to the robot. You can run that code on the robot without battery brownouts crashing your processor. I mean, it's a huge step forward. That's why we give out the
star. And to be competitive,
gold stars. Exactly.
And to be competitive, you got to go fast on that contest. Because Carl's kind of like set the record. He doesn't turn around. He doesn't do anything. He just drives out and comes back.
Well, so what you need to do is now to modify the contest. So not only do you have to navigate, but you have to pick something up.
I agree that we do. If you look at our first outdoor contest, it was basically drive to a cone that was 100 feet with nothing in front of it. That was the very first, not 100 yards. 100 feet.
100 centimeters.
Yeah, almost. I mean, it was really, it was much simpler contest. And now it's, 3 cones, 100 yards apart, obstacles between 2 of them, so it's an evolution thing. I would say that, the next one we usually do is 4 squares, which is just the
B mark.
UMB mark.
Yeah, B mark. Yeah. And then the next one after that is tabletop, but that's sort of specialized. That just raises the bar. You learn to go places without falling off. It really kind of focuses the mind. Because if you're going to do it right, you've got to be cool, which means you don't go.
That's right.
around the edge of the table.
You need to have a contest where one of the goals is to manipulate the environment. Opens up a whole new set of possibilities.
We've got one queued up someday. The rules have been written, and it's kind of like a indoor version of the contest that they did outside just recently, where robots go out and they're out on a big mile by probably 200 yards by 200 yard field, and they got to pick up objects and they bring them back to a main base. That's all out there. We have the rule set. You can look it up. Well, the attempt was to try to have 5 objects that were different, that you would have to have some sort of visual recognition of the object. So that's pretty complex, and we've never actually ran that contest because we've never got 2 people who are or even 1 person who's willing to say, yeah, I'm ready to do it.
Well, basically, it's just like outdoor can, except that the objects are different. When can started, the idea was that we would actually have real soda cans out there, and that basically your robot was going to pick them up and put them in the recycling bin. Then after a while, it was decided that the cans should be all painted orange to make them easier to find, which was the first cheat. And they also don't look like Coke cans anymore. And now we deliver them to a goal rather than a recycling bin. Yeah. So I had suggested that we have a contest and we call it hazardous waste. And it's pretty much the same rules, except the orange cans are full of hazardous waste. And you have to pick them up without dropping them or knocking them over. If you drop them and knock them over, it kills everybody in the room.
Yeah. Well,
you could use
but it would be nice. The orange cans lead to an obvious next step, and that's to not have orange cans. The reason we use orange cans was to try to bring people up to, okay, I'm now going to use a camera. It's going to be a blob detector, but I'm going to use a camera. Where robots before, or tests before that, if you're going up the progression of tests, you didn't need a camera to do it. That one you don't need a camera either. I've seen people do it with ultrasonics, but it's easier with a camera. And the next one would mean that you would have to have object recognition. Okay, I'm sure somebody can figure out how to do it without object recognition, but that would be the easy way to do it. Do you know what I mean? So it'll be, as far as you want to go down this rabbit hole, you can keep developing skills.
I bet this thing already comes built in with the ability to recognize all the objects that we want. I know it can recognize orange cones and beer bottles and so forth.
Can it do Smurfs?
I believe it can differentiate between subtle flavors of brandy.
Okay, hold on a second. I'll show you the 5 objects real quick, since
I'm sure it could be trained to recognize Smurfs.
Yeah, I don't think I remember Smurfs being on any of the lists for the models.
These were the 5 objects that were on that test. Coke can, robot wheel, a Smurf, baseball, and a block. So
you're
those,
holding the block out of frame. Oh, there it is. Other way.
There you
There you
Here
go.
we go.
So a block, a baseball, Smurf, a wheel, and a Diet Coke can.
I like those because they're all lightweight, although the baseball is probably the heaviest, isn't it?
Probably.
Grabbing a ball is not easy.
My team's robot can do all those. I'm pretty
Yeah,
sure.
that'd be great. That'd be great. Why aren't you going to do it?
Well, maybe another factor
Well,
here
have
is
this pay. Hey, no, really, Kareem, if you guys are ready, could do that.
I
can
could
run
have him work on that. Yeah.
Yeah, I can have them run this contest on. The rules are up there. You can take
Is
a
this
look at it.
outdoors? I mean, is there a robot?
No, it was meant to be indoors.
So
It
is
was
the
meant to
robot
be
too big?
indoors. I think there's a square that you start off in, and that's where the things have to come back to. But you don't know anywhere. The objects can be anywhere in the room. Okay, now the intent was, we would make it easy for the first time, and then it would get more complicated. We would, otherwise, probably at first, all the objects would be line of sight, but eventually you would have to go search for them.
Easter egg hunt.
Huh?
Easter egg hunt.
Right.
Yeah, but consider that as the task becomes more complex, so does the robot and the cost of the robot as well. Almost everybody here operates as an individual. It's almost like you need to pair up or you need to have a team to have a robot that's sufficiently complex to handle a complex task.
Well, I don't actually, John. I think if you had a navigating robot, otherwise robots that could go to waypoints, a robot that had probably, a Raspberry Pi to be able to handle the video, handle the neural net stuff. There, it could be a Jetson, or it could be, they're all certain things. You're well on the way. It's not an expensive robot. Is
What you're missing there, I think, is the manipulator.
Well, manipulators are pretty well.
You
would for the yeah.
Well, I mean, a simple
everything's
let him go.
Everything
a
is
simple
easy.
gripper is one thing, but anything
John,
like
I will say that there's a different approach, maybe, and if you look at what Kareem's teams have done over the years, or that the approach is that rather than having to build a new robot for each contest, that you have a more general purpose robot that can be tasked to a particular contest. So you say, okay, for this contest, I'll need some light sensors that I never used before. For this contest, I need a gripper and so forth. But you already have a sophisticated robot that can do all kinds of things that can be then turned toward this particular task, rather than trying to build a robot from scratch for each contest.
Right.
Or at least that's what I
agree with you, and that's what the 2016 robot base the club made. That was the intent of that, was to provide everybody with a goodish robot that they could use as a pretty standard base. And by the way, if anybody wants the hardboard parts of that, I can make them a set, if you want it. So you'd have to buy your wheels and your motors, but those Polo type things. Let me show you one.
Hey, Paul, you got anything to present?
Hi, Paul.
This is an example with a modified front. The front is one of the reasons this was one of the design features with it. You could customize it very quickly. You can see in this case, John, I'm not using a claw or anything. I'm just using a barrier. I scoop them up. Okay.
Mm-hmm.
The original one looks a lot like David's. What's the newest one you got, David?
The RCAT? The SR04 was
Yeah.
was my first. This one was the RCAT that I built for the to blow soda cans around before they changed all the rules. You know, rule makers hate real innovation.
I love the leaf blower. It's great.
Well, I may get back to that. What I'd like to do is make it smarter. Make it do like SR04, locate, grab a can, rotate toward the target, and then shoot, rather than just sort of generally shooting.
Yeah, when you talk about rules like that, the Robot Wars series comes to mind, where they had to keep modifying the rules because people would come up with things like, throw a net, tangle the other robots' mechanisms, and they you can't have nets anymore.
Well, if you watched what happened with sumo, full-size sumo, it got so complicated. They were using rare earth magnets to hold the robots down to the surface so that they couldn't be shoved away. And then after a while, they used vacuum cleaning systems to basically to suck the robot down really hard to the surface and make it hard to shove. And if you weren't in that ballpark, you couldn't play. There's no way you could defeat them. And as one of my friends used to say, if you don't like getting hit in the face, you shouldn't put on the gloves and get in the ring.
Yeah.
I always wanted to play around with pneumatics, like what you could use in a gun, the little CO2 cylinders, and have, they basically puff out a blast of air, like on the top of the can to maybe, flip it forward into the goal. Never did any.
Well, Doug had actually encouraged me, and I looked at a bunch of different things. I looked at trying to hit it like you had a golf club, to whack the can and see if I could. Cans don't necessarily go in a straight line. I built a, what's it called? A big box that fires out a
like a torrent or a.
Yeah.
You mean the leaf blower one?
Toroid, I guess, of air.
Yeah, it's like a toroid of air. Like a smoke cannon.
Vortex cannon. Yeah.
Vortex. Thank you so much. I used to have a good mind, Kareem, but it's been addled. Yeah, vortex cannon, and I actually made one that could blow cans over, but it couldn't move them. It could knock them over, but it couldn't move them.
Yeah.
So I tried a whole bunch of different things, and that's when we finally settled on the leaf blower. And the first experiment I ran with it, if you got 6 cans out there, I could get all 6 cans through the opening in 20 seconds or something. And then the rule was changed, so you have to go through 1 can at a time. And if 2 cans went through, they picked one up and put it back out. That made me pout.
Actually, that was before you did the leaf blower thing, but we wanted to see the leaf blower. It was really cool.
Yeah,
I think there's a video of it.
Yeah,
I think there's a video. I think there's a video of it in the archives.
What I found was, without really knowing where the cans were, just by sweeping the different quadrants of what would happen is cans would end up down in the corners. They didn't make it through the gate. So then I added a behavior that drove down to the corner and got close to the wall and would sweep out the corner. And generally those would roll over close enough that the next blast would knock them through the gate.
Somebody needs to come up with a robotic mechanism that works like the tongue on a chameleon and sticks to the can.
Good idea.
Yeah, there was a group at the Makerspace. It seemed like they were all playing a overblown game of Battleship. They all had these intricate models that were made out of, I guess, wood and plastic. And
balsa wood, yeah.
Oh, was it balsa wood? Okay, yeah. Anyway, they had pneumatic systems in them with, like a canister that held compressed air or CO2, like a kind of like an expansion chamber that would hold the puff of air. And they had this complex mechanism to load. I think they were like 1/4-inch ball bearings,
They
and that's
were
what they shot at each
quarter-inch
other.
ball bearings.
Yeah, to try to sink these ships. And I thought, okay, I could probably use the the CO2 cartridge and the accumulator and whatever valve they use to send out a blast of air. But it'd probably be like kind of like you said, David. It'd probably be pretty short range. I don't know how far it would go. It may be a lot of work.
It looks really cool. If you put some smoke inside the box before you shoot out, you can see the smoke ring will travel all the way across the room. It just doesn't have enough power. But the smoke ring,
okay.
just watching the smoke ring is very cool.
Yeah.
So that might be worth it just by itself. John, I
Pretty
did have
loud, but the
Lego
cheaper
robot.
alternative is to use those little 22 shells that they blast nails into concrete with. I bet you that would have enough power. It'd probably be pretty scary though. All of a sudden you hear gunfire at the
More
makerspace.
power, more power.
They did at the makerspace was these where they put a vacuum into the tube and then put pressure on the other side and fired ping pong balls. Well, they used filled them with water and froze them, and were putting them through PC cases.
Ooh. Yeah,
That's pretty scary.
Sometimes at the makerspace is a lot of free spirits. Sometimes they're a little too free. I mean, it's a great place though. Hey Kareem, I feel like you've accepted the challenge to run that contest at next May. When is your other schedule for all your other stuff? Is May a good time?
May's a good time. Yeah. We just washed out this weekend on
Okay.
on the Worlds track, but we're April is our early April. We'll be going to state, I think.
Mm-hmm. Okay. All right. Well, that's cool then. So we got one contestant now. If we can see if we can get somebody else, that'd be really cool.
If you're thinking having a contest in May, though, I would suggest not on the middle of the May because I will have something else I need to do then. So it needs to be at the latter part or else the beginning part.
Well, we'll figure that as it gets closer. But
I know.
We just know in May somewhere.
I'm just telling you, I already have a scheduled blacksmith thing scheduled on the 14th, give or take. I forget the exact dates.
Okay, now Pat, I got a question for you. Okay, you participated last time. I know you didn't get a chance to run your robot.
This is a robot.
But you were going to virtually do a contest. Did you get anything out of our trying to stream that to you? We were trying to stream it, but it was very confused.
I watched I didn't go to location because I was having bad luck with the robot.
Yeah, I got that.
I streamed it and I thought it was actually excellent. I know that it was a lot of work for you guys to do that, but I was generally impressed. I got the good feel of what the contest is like. And, aside from the video stuttering once in a while, and as you got farther away towards the second target, it would freeze up once in a while. But I thought it was excellent.
Well, the biggest problem with it was probably the fact that we had such a distance and we didn't have really a lens to zoom in per se.
Yeah. So and guys were doing it from their phones and stuff like that. And I thought it was excellent. It was got a really good idea of what was going on there.
Okay, well, good then. Because what I'm saying, if we have a contest in May, if we could allow to do that remotely too. So you can go out and look at the contest rules. Make sure you got a place that's suitable to do it. You're going to probably need that room, the library room or something, to be able to do it. And we'll try and have virtual contests of the contests that we run this year. Does that
Okay.
sound good to you? They'll probably go, they go a gamut. There'll going to be some that are really simple, and there'll be some that are a little more complex. And then we got this new one, which Kareem's going to run in. That's going to be probably the hardest one to do.
Okay, I'm definitely interested. Timing, it depends exactly when it is in May. If it's at the end of May, around your long weekend, I'm disappearing. I'm heading west for 6 weeks.
Okay.
All
right. We'll
my retirement to use.
There's no reason why we have to do it on the same day here as you. We can watch you. You can set up a camera or a phone somewhere, and we can watch you guys do your stuff. It'd be nice if they're all on the same day, but I'm saying if it isn't, we can still figure it out.
Well, I could send you a video, and you guys could play it on. If it's late in the month, you could play it on YouTube. Okay. Otherwise, if it's mid-month or earlier, I don't see a problem with it.
Okay. Well, we usually do the second week. John says he can't do that, but we'll have to see and figure out something. Okay.
Well, I think it's like the 11th through the 14th or something. I'll have to look at the calendars but there's basically a national blacksmith convention up in Denton. So
that's pretty cool.
Yeah. So
can people just go up there and watch?
Yeah.
Oh, that'd be fun.
I'll have more details actually this next month on it, but yeah.
John, I
tie up with that.
I had a friend that used to go to that, or whatever its equivalent was. Back in the last century, he was an artist that made things like fancy gates for rich people's houses and stuff like that. And he would come back so excited. He would say, 3 days, a guy is talking steel, talking iron.
But in the meantime, I do have something to show that is not metal, but I'll show you this all because y'all talk about lifting things. So you'll probably find this of interest. So seemingly on Throttle, there's a gear reduction robot arm out there. So, and I'll replay that. Yep. So, but basically it talks about gears and different types and that. So it's probably a good article to look at. I just saw it today. So, but why use the gears, the types of gears out there. And then it looks like it goes for the planetary gears, seemingly it's the best, for the arm. And it actually talks about design. So yes, so if you do buy that a $99 printer, here's something you can print out there.
Cool.
Yeah, I wanted to ask, is anybody going to the part-to-part show in Arlington starting tomorrow?
Oh, gosh. I went last year. It was a lot of fun.
Yeah.
And I didn't realize it's tomorrow.
Yeah, tomorrow and the day after.
Okay. You want to?
Yeah, it's one of my favorite thing to do. I can't take off work to go do it.
Yeah, I was going to say.
Yeah. Where is it? Where's the facility where they're doing it?
It's in Arlington, isn't it?
Yeah, it is.
Yeah.
I could get one of the.
Can you post a link of the notification or whatever it is?
Yeah.
What is part to part?
It's a bunch of vendors who can make they do different parts like water jetting or
okay,
that type of thing, and it's really cool because it can be PCB board fabrication, it could be, but there's a surprising amount of these services that are available fairly close, like McKinney or someplace like that. And some of them will they're usually a little pricey for us, but I did see some things that were on the edge of what I'd say, well, I could probably do a one-off on that. You know what I'm saying? A lot of them will tell you, nah, we won't deal with anything less than 1,000. You learn to go up. There's certain questions that you learn to ask them, like, do you guys do prototypes? Blah, blah, blah. What is a typical prototype cost? You learn to ask the right questions. You can find, and plus there's a lot of swag. So the swag is fun. You never know what you're going to get. There's a list of swag that you consider if you've made it. One is you get a 6-inch steel ruler. That's one. If you get a tape measure. If you get a laser pointer. If you get a plastic caliper. If you get, there's all sorts of a squishy ball. You can kind of like make your.
I don't know. I was talking to a couple of those vendors, and they said, "Hey, you're pretty interested in this stuff. Here, let me send you some samples." And so it took all my information, and about 2 or 3 weeks later, I got a bunch of samples of different kinds. There's like 18 million kinds of super glue that do different things, different viscosities. He sent me 2 or 3 of those things. I put them in the refrigerator so it lasts, and I use that kind of. I had no idea why. He just kind of liked me and sent me some bunch of samples and stuff.
So this is something that they 3D somebody over there. I guess it's a resin. This is actually from HP, and it's got. I know you can't see it here on where you are, but it's got this really incredible textured outside, and I mean it's just really.
There's a couple of cats around town that have those printers that I've ran into. That's printed in place, and that's and that's HP does the particle thing where it lays down a row of particles. Then imagine this: a fuser goes over the top of it and fuses those things at the level, and then it lays another thing down. So you get this big block of stuff, but it makes its own support as you go. And a couple of things with that printer is the stuff that doesn't get fused, they reuse 80% of it in the next one that you do. And one of the other weird things, because the cooling matters on this, you're getting a big block like this of stuff. So you're printing thousands of those little things at the same time, or thousands, hundreds, something. And it has to go set for as long as it took to make. So if it took 24 hours to print that block, it needs to go set somewhere for 24 hours in a cooling chamber before you can undo it. So, and if you're thinking about getting your one, I want to become good friends with you. I want you inherit me, you adopt me, because the base price is $350K and a usable price is about $500,000 for that setup.
Anyway, it's a lot of fun. I went there last year with my daughter and really enjoyed it.
I was blown away with all the stuff. I mean, one of the vivid memories I have, there's a cat. He has a table out there, and they built springs. And you wouldn't think you could have all kinds of springs, but you've got little springs and big springs and springs that do this and springs that do that and compression springs. And he had a whole table full of all the different kind of springs they do. And if they didn't, none of that fit, they could make your own spring.
One word, tanners.
Cannons.
Tanners.
Oh yeah, exactly.
But they can't make custom springs. That's the only problem with that. So.
Yeah. Well, and again, I what I'm saying is, and like Doug was saying, they don't want to make one of those springs for you. They want to make you 10,000 of those springs. So, it's a little limited use to most of it.
I know they told me this, but I wrote it down, but dang, I can't find it. Who got the gold star tonight?
Ross.
Oh yeah, Ross. Okay. Okay, I know I got it. Oh yeah, Ross Murphy. I found it now that I got the first note. Okay.
Be sure and put down that he's a Canadian.
I'm going to bail for the night, guys. We'll see y'all.
Yeah, we'll see y'all. Yeah, I'm going too, guys.
Yeah,
Been
me too.
fun.
Yep.
Well,
Yeah, I
who's
should
doing the
probably head out
recording
myself.
for this thing, by the way?
Carl.
There's
Carl
Carl came in and started the recording then?
Yeah.
there's
Yeah.
3 windows that say Carl Ott.
Okay. Okie doke.
So,
All right. I'll be expecting it so I can post it. Okay.
okay, so
Later.
see
See you
you all
guys.
later.
Hey, anybody was in the beginning? Paul, were you in the beginning? Oh, okay. All right. I hope Carl's got the chat too. Okay. Bye, guys.
Good night.